pi and under pi of this. So we change because pi is in like under 1.2 under pi, here 1.2 under pi. Okay, so that is there. Now in this case, this is 2 upon 2 here. And this value will come out to be as, let me write here, it's even integer. So what do we obtain here? That the above value, this is nothing but n plus 1 upon 2 gamma n plus 1 upon 2. This value is, because gamma n plus 1 upon 2 will be this n minus 1, this is n minus 1, n minus 3 upon 2, n minus this one, and this is gamma n plus 1 upon 2 divided by value 1. This whole is equal to 2 and this whole is n plus n plus 2 upon 2. Okay, so why I've taken this 2 this started from n upon 2 n minus 2 upon 2, this sum, and this value is here, and this 2 is the pi upon 2 are taken here, and this pi by under pi into pi, pi, this is n minus 1 n plus 1 factorial, n plus 1 upon 2 factorial, this is n plus 1 upon 2 factorial. Okay, so we will obtain, if I subtract minus 1 here, minus 1 from this, we will get n minus 1 upon 2. Why? Because if I write n plus 1 upon 2 minus 1, next will be, next factorial will be, okay, next, this is n plus 1 upon 2 equal to this gamma, same value, will be n minus 1 upon 2, because minus 2, n plus 1 minus 2 upon 2, that means n minus 1 upon 2. Okay, so this can be written as this. First one, this is n minus 1 upon 2 into gamma n minus 1 upon 2. Gamma n minus 1 upon 2 can be written as n minus 3 upon 2. Okay, n minus, in this way, this n minus 1 upon 2 is here. This n minus 1, gamma n minus 1 upon 2 will be n minus 3 upon 2. Gamma n minus 1, n minus 3 upon 2 gamma. Okay, n minus 3 upon 2 into gamma n minus 3 upon 2. This is equal to. In this way, this first one is expressed here. Okay, so this is what we have obtained. In the denominator, we have obtained this by subtracting here minus 1 into minus 2 to n plus n upon 2. First one. We'll subtract again from m plus n plus 2. Okay, and this one. If I again subtract this minus 2 from n plus n upon 2, it will be n plus n minus 2 upon 2. Okay, so in this way, this is the expression. But this 2 has come from pi by 2. The 2 is here. This is pi of gamma. This whole value is gamma m plus n upon 2. This is the value when m plus n are integers. Sorry, m plus n or m and n both are even integers. Okay, so this is the value which we are obtaining. Now, if I express in the same way, if m is odd, let me write here. The second condition, case number second. Case number second, this is case number 1. Case number 1 was when m and the n both are even numbers, even integers, let me take. Both are even integers. So the first case. Second is if m is even and n is odd. Okay, so if I write here, the same value will be obtained. If I write in place of okay, sine in place of sine, because m is here even, the same value will be obtained. Only the last value will be 2 by 3, not 1.2. 2 by 3 will be last value. But sin x, sorry, cos x is cos x, and it's odd function last. So if n is odd function, then last value sin n odd. So this cos is not cos nx we have taken. I'm not reducing here. The last value will be n1 only. Cos x will be there. Or here we have taken sin nx, or it may be cos nx. Okay, and last will be cos x. Okay, I'm sorry. Last will be sin x. This is cos x. cos n cos nx. This will be cos nx answer. Be cos nx. Sin x will be left over because one power will be there, not 0. Last step will be sin x into cos n power x into bx. 0 to pi by 2. Because it is odd function. I'm talking about the second part. First part will be the same. M minus 1 upon that. Okay, m minus 1 upon m plus n, and then m minus 3 upon m plus n minus 2, and so on. Last will be 2 upon 3. Okay, and then this function will be there. Fine. If I take cos x as t, here cos x equal to t. So minus sin x dx will be dt. This minus sign will be here in the end. This minus sign here. But here it is t raised to power n plus 1 upon 2. That means cos raised to power n plus 1 x upon n plus 1 will be there. In the end, when we substitute 0 to pi by 2 limits, that pi by 2 is 0, but this is minus sign, but minus sign is there because of this minus dt. But so lower limit, when we substitute 0, it will be 1 upon n plus 1 in the last value. Okay, so last step will be 1 upon n plus 1 in the end. This value will be, the same thing will be there. If I express the same thing, okay, so in case this is, let me write here. What will be the value? The same value will be obtained here. What is that? M minus 1 upon n plus n. First step will be m minus 3 upon m plus n minus 2. So this is the first step of sin mx cos nx. That will be, this series will be for sin mx, but this is odd function. And the last step, let me write here n minus 5 upon n plus n minus 4 and so on. Last step here, it will be 1 upon n plus 1. This was there, 1 upon n plus 1. Okay, and the last was, first was n minus n plus 2, and then n plus 1 was the last one. But here it will start as 1 upon n minus 1 with n minus 1, or n minus 1 upon n here, and n minus 3 upon n minus 2, and so on. Last step here, because even function, it will be only 1 in the end. Okay, before that it is 2 by 3, sorry, 3 by 2. This is odd function. First is odd function, and this one is even function. So under root pi will be there in the first function. And here it will be under root pi in the first function. Second will be only 2 by 3 in this one. Before that, the first one, if I write here under root pi, because 1 upon n plus 2 up to this point, here under root pi. Okay, so this is 3 by 2 here. Okay, so, and then under root pi we have to multiply this, and here also we have to multiply that numerator. That value will come out as. So this is, in case odd function it is there. In the end, here it is m plus n. Okay, m plus n upon 2. If I divide each term by this m plus n upon 2, divide by 2 each term, the same value will be obtained. Okay, so this is the same function. If I express the same thing here again, and for m is even, n is odd, the same function gamma n plus n, gamma n plus 1 upon 2 into gamma n plus 1 upon 2, straight line, not a square type. This will be this is upon n plus 2 upon 2 into gamma, this is m plus n plus 2 upon 2. Same value in case n is even and n is odd. Now if I substitute here in place of pi by 2, let me write here, if we substitute the angle as pi by 2 minus x, pi by 2 minus x, then the similar result, will be obtained. Similarly, it will be obtained for when n is even, n is odd, m is odd, n is even. But for n is odd and n is even. Okay, so n is even. This is what we have obtained. So n is even, m is odd. Here it was m is even and n is odd. Here it is m is odd and n is even. This is case number 3. Case number 3. This is case number 2. These two are similar type, but only they have to replace angle of sine or cos both by pi by 2 minus x. This angle will give us, if it is sine, it will be cos x. If it is cos x, it will be sin x. In this way, the same result will work. Okay. This is what the two cases are here. Now, if I take when both m and n are odd functions, that situation, what it will be? If case number 4, when m and n both are odd functions, okay, so in the end, what we get here, only the sin x will be there, sin x 1 forward, and cos the end also we will get 1 forward. Now cos x is again differentiated, versus sin x into cos with power nx, and in the end when cos n is expressed, so the first step for the first one is 1 here, 1 is obtained. In this case, first one, let me write here. In that case, 0 to pi by sin mx into cos mx into dx will be equal to the same value m minus 1 upon m plus n, m minus 3 upon m plus n minus 2. The same series will start here, m minus 5 upon m plus n minus 4, sorry, n into and so on. Because it is odd function, the last function will be 3 by 2 into only 3 by 2 here, not 1.2, because this is 3 by 2, and the last function is 0 to, let me write here, 0 to pi by 2. It is sin x, okay, sin x is odd function, and cos therefore still nx into dx. Cos is for nx. This is first function, but after that this cos nx is expressed for sin x here, we cos n plus 1 by 2. So that value is there. This can be expressed as now cos nx. If I write here sin x, it can be taken in the cos n plus 1 x upon n plus 1. This will be the first step. If I write the limits in 3 by 2 into first will be minus sign here, cos will power n plus 1 x upon n plus 1. Okay, still it is, and then the other steps will be there. This is the first step, and after that the end will be n minus 1. So here we have started n minus 1 upon. The last step in this case is 1 upon n plus 1. Okay, so just let me write here. This step will be 1 upon n plus 2. Then it may start at 1 upon n, 1 upon n, and then 1 upon n minus 2, and so on. And last step will be 1 upon not 1 upon 2 but 2 upon 3 upon 2. Okay, here it is because odd function is there. This is odd function. Here also we will get 3 by 2. If I let me now divide them each term by 2, it will be m minus 1 upon 2, m minus 3 upon 2, m minus 5 upon 2, and so on. This is 1 upon 2. Before that is 3 by 2, it is 5 by 2, and so on. Okay, so this is 1 upon 2 here. Now in the denominator we will get these terms. Now then This 1.2, I'm sorry, this 1.2 here, 1.n plus 2 we have taken. Here it is 1.n, no, this is 1.n minus 2 by 1. This is 1 upon n plus 2 is the last step in this case. Before that it was 3 by 2. Okay, sorry, 3 by n here. Then 3 by n plus, I'm sorry, this is not n plus 2. Last step is n plus 2, then 3, then n by 2. Here it is n, and here then it starts as n minus 1, n minus 3, okay, and so on. And last step is 3 by 2. Okay, and I multiply this is 1.2. Okay, so this value is finally I'm just writing 1.2, 5 by 2, 3 by 2, up to this 3 by 10 with then, and so on, then n by n minus 1.2. This starts, then n minus 3 upon 2, n minus 5 upon 2, and so on, 3 by 2, 1.2, divided by this n plus n upon 2, n plus n minus 2 upon 2, and this value n by 2, this is n plus 2 upon 2, okay, then n by n plus 2, n by 2, n minus 2 by 2, and so on, last 2 by 2, and this 1.2 will come here, twice of this value, and this is 1 to 1 only. Okay, and then pi by, if I write here under pi, because under pi is there, in this case this is sorry, odd function, each is odd function. Under pi, and pi, we have to multiply both. It will be then n plus n minus 1 upon 2, or n plus 1 factorial. The final answer will be here. Let me write. So the same value will be of the first one is n plus 1, n plus 1 upon 2 gamma into gamma n plus 1 upon 2. The second part divided by twice gamma n plus n, sorry, plus 2 upon 2. This is the same value here in odd function also. Okay, if there is any problem, I'll just explain this again. So if I take by Wallis formula the second part in the by first form, first by I m n, you have to be expressed in I m minus 2 and I m. Okay, and I m we have expressed here I m n 2 in terms of I m minus 2 and n. In this way, if it is odd function, then after n, the last value will be 1 only. Okay, because here it is not pi by 2, but because cos is for n plus 1 upon n. If I put here limits 0 to pi by 2, 0 to pi by 2, at pi by 2 is 0, but with the minus sign here before, it will be 1. Last value will be 1. In this way, the same expression will be obtained. Okay, so all the 4 cases you have to know about. How to express them, that is one of the points. You will take Wallis formula for the nth power, cos of nth power, or sin nth power. If I express sine, then it will be plus sign here. Sin is for n minus 1 into cos is for n plus 1. And in the last term will be cos, sorry, sin is for n x, and cos n will be n into cos nx, into cos x into sin is for nx. That can also be expressed with the help of what you call considering sin x as t and cos x dx dt, cos nx, sorry, sin n plus 1 upon n plus 1. In this case, sin pi by 2 is 1. Positive here. That is the last one to be the one here. So the same value is obtained. Okay, so far as under pi is concerned, because the last term will be 1.2 under pi. Okay, and second will also value pi. The denominator also will get under pi. Then that under pi can be multiplied and divided. The same function unity will be obtained. This is what we obtain, the same gamma function. We can express these values in gamma function. If there is only sin nx, there is no cos nx. Okay, if This is also valid for, let me write here. This is also valid. This formula is also valid for. Let me write. This formula is also valid. Is also valid when a single trigonometric function is given. That is, if I express sin of it is 0 to pi by 2, if it is only sin nx, no cos x is given, then also we can apply the Gamma function. In this case, the second function n can be taken as 0. Okay. That will be 0 here. This will be, if it is n here, then n plus 1 upon 2. And second m is 0. Second will be only 1 upon 2. Gamma 1 upon 2 and pi. And this also will pi will go to pi here. This is the value divided by twice into n plus n. Now for the n is 0 here. This is n plus 2 upon 2 gamma. This is the value in case of when n is given only. No m is 0. So m is 0 and we can substitute m0. This was n plus 1 upon, sorry, gamma n plus 1 upon 2, but n plus 1 upon 2 gamma, but m is 0. So here we can substitute. In the denominator we have m plus n plus 2, so m is 0, n plus n, or n plus 2 upon 2 only. Twice is there. So this is the value of a single function, that is a single trigonometric function, sin nx or cos nx or sin mx and cos nx is given. That can also be expressed in the same way. Okay, so this gamma function expression is valid for single trigonometric function also, that we will use. Okay, so now let me take questions one by one. Okay, so this is what we have proved, that all the four cases, this formula is valid. So this gamma expression for definite integrals when limits are 0 to pi by 2, for definite integral when limits are 0 to pi by 2, only then this formula can be applied. Okay, so now let me take. Okay, sorry. Question number second. Now question number second, let me take 0 to pi by 2 sin 4x. Here it is cos square x dx. So expressing the result of this can be obtained by applying gamma function expression. Gamma function expression taking gamma function expression taking what? Taking gamma function expression taking m is equal to 4 and n is equal to 2. Therefore, this 0 to pi by 2, okay, sin 4x cos square x dx is equal to gamma 4 plus 1 upon 2, gamma 2 plus 1 upon 2 divided by twice gamma 4 plus 2 plus 2 upon 2. Now let me find out the value. This is 5 by 2. Okay, so gamma 5 by 2. This is gamma 3 by 2. Divided by twice gamma 4 plus 2, 6 plus 2, 8. 4 plus 2, 6 plus 2, 8. 8 upon 2 is 4. Okay, so only 2 gamma. Now let me express this. This is factorial 3 in the denominator. Here it is 3 by 2 into 1 by 2 gamma 1 upon 2, the first one. Here will be 1 upon 2 gamma 1 upon 2, first one. twice into factorial 3. Factorial gamma 4 is factorial 3. Now what is the numerator value? 3 upon 4 gamma 1.2 is under root 5. This is 1.2 under root 5 into root 5 divided by 2 into factorial. This is factorial 3 is 6, so 3 into 2 into 1. What do we get here? 3 upon 8. This is 3 now cancel out, so 3 cancel out. 8 will come here. 8 for the 32. Pi upon 32. Pi upon 32 down. By 32 will be the 4 in the denominator. This 8 will come in the denominator. And root pi into root pi is pi. Pi upon 32 is down. Question number second. If the question was second here and here. Let me take next question. Okay, question number now third. What is that? Question number third. What is that? Okay, question number third is sin of a from 0 to pi by 2. Alright, this sin 5x into dx. Now here m equal to 5, n equal to 0. What is this value? By applying gamma function. Okay, by gamma function expression, the value of this integral, the value of the given integral, the value of the given integral will be, okay, so this will be what? This is 5 plus 1 upon 2 gamma, and this is gamma only 1.2 because n is 0, n plus 1, sorry, n plus 1.2, that is 1.2 only, but that twice gamma 5 plus n is 0 plus 2 only on 2, 5 plus n plus 2 upon 2. In the numerator we have obtained 6 upon 2 is factorial, sorry, gamma 3. 5 plus 1, 6 upon 2, 3. And this is under root pi. Root pi, because under gamma 1.2 is root pi divided by factorial 2 only. In the denominator we have 2 factor to 7 upon 2, gamma 7 upon 2. What is this? Let me write. 2 factorial 2, that means 2 into 1 under root pi divided by 2 into 5 by 2, because gamma 7 by 2 is expressed as 5 by 2, 3 by 2, 1 upon 2, gamma 1.2, this 1.2 gamma is, so this 1, 2, 2, cancel that, you cancel out by this, okay, this will be the 4 to the 8, 8 will come in the numerator, at 15, this is a root pi and root pi cancel out, this is also a root pi, 1.2, so 8 upon 15, by 3 of 15, and this 2 to the 4 to the 8 will come in the numerator, 8 upon 15 is down. Okay, so this is answer of question number from third one. Let me take the fourth question. Now question number fourth is what? Now question number fourth. Let us talk about it. Okay, this is sin of integration 0 to a, okay, x square within bracket it is a square minus x square whole power 3 by 2 dx. Now if I substitute here x equal to a sine theta, which means just putting or substituting x equal to a sine theta, differentiating it with respect to theta, differentiating it with respect to theta, we get, what do we get here? This is dx upon d theta is equal to a into cos theta, or dx equal to a cos theta into d theta. Limits, let me substitute here. A, if when x equal to a, sin theta is equal to a upon a equal to 1 equal to sin pi by 2, because 1 is sin pi by 2, therefore theta is equal to pi by 2. Limits, this is limits here. For limits we are calculating. For limits theta is pi by 2, and when x is 0, when x is 0, then theta is equal to, because sin theta is 0 and 0 is for 0, sin 0, and so theta is 0. When x equal to 0, theta is equal to 0. So now let me substitute the limit 0 to pi by 2. Limit here is x a square sin square theta. First one, from the bracket we will get a square minus a square sin square theta whole 3 by 2. Dx is a cos theta d theta. Okay. Now what do we get here? This is 0 to pi by 2 a square, and from within the bracket we will get a2, where a square, if I take common, a square power in this a, this 2 power 3 upon 2 will be cancelled out. Power 3 will come out. It will be a square into a sin square theta. From bracket we will get cos square theta, because 1 minus sin square is cos square theta. Cos square and this is 2 power cancelled out. Cos q theta into cos a cos theta. 1a is a is also here. a2 here. a2 from bracket and a2 a square and a2 it is a6. Now into cos, one more cos here, into d theta. Now let me further express this. a6 can be taken out. It is constant value 0 to pi by 2. It is nothing but sin square theta into cos whole theta d theta. Now applying the